Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into Chapter 3 here in Modern Math and talk about fair division. Okay, what does it mean to divide things fairly? All right, and we're going to be talking about the different terminology that's used, all right, when discussing fair division games. And we're going to get into some examples as the intro of the chapter here. So let's get right into it here. You might want a calculator, so take that out. We might use it for some of the arithmetic. And take out your red pen for highlighting and annotating. And here we go. Okay, so when it comes to fair division games, at least in this context, in this book here, there are something called goods, players, and the value system. So let's do little definitions first and explain some of the main concepts that we're going to be using in this chapter. So, goods. What are the goods? Well, the symbol for goods that we use, or that the book uses, is S for good. So when you divide something, whether it be pizza or a cake or a piece of land or whatever you're dividing, those are the goods or the assets. Okay, and they're the items to be divided. Now, there's two types of items that typically are divided: the physical ones and the intangible ones. So, in respect to the physical items, or objects to be divided, I'm talking about pies. You know, if you want to divide a pie, you can do that. You can divide a pizza. Okay, that's commonly happening, especially when you go out to dinner to a restaurant. You have to figure out how to divide the pizza fairly so that everybody gets their fair share of the pizza, right? Okay, land. You could divide land in, let's say, uh, well, that happens all the time, whether it's just purchasing a piece of land, or sometimes, people don't make it and they divorce, so they have to piece off the land, right? And they have to do so fairly. So sometimes you have some physical objects like that. Intangible objects or intangibles, well, those are the things that you can touch, right? Intangibles. All right, what am I talking about? I'm talking about rights, and I'm also talking about chores, something like that. Uh, that are intangible, but you have to divvy up the responsibilities, right? The chores, and you have to do so fairly so everybody's happy in the end result. Okay. Now there's also called the players. Now the players, we use P for players. Those are the people or the groups or the institutions involved that are entitled to share the goods or the assets. Okay. Goods, assets, the same thing. Okay, that's another name for goods that I use. All right, so I'm talking about the people involved. I'm talking about there may be groups involved, or it may be companies or institutions, right? So uh, the players are either the people, the group, or the institutions involved that are dividing the assets or the goods. When doing that, though, there's something called a value system. Everybody has their personal preference, right? A player's internal ability, okay, to quantify, which means measure, all right, which means assign a value to the goods, okay? Assign a value. I'm talking a monetary value or a percentage value, something like that in that nature. Now, when that happens, not every player will have the same value for the given object or whatever the goods may be. So let's put that down. It's a very important point. All right, because everybody has their own personal preference. So not every player, all right, will have the same value. Okay, underline the word not too. Not every player will have the same value for a given object. And or what I mean by that is I'm talking about the goods, okay, that are being divided. Now, we're going to be talking about things in absolute terms and sometimes relative terms. So what does that mean? Okay, absolute terms means that we're talking about the worth in, let's say, in dollars. Okay, we're going to assign a worth in dollars, and I'm talking about a monetary value. Okay, sometimes we talk about it in terms of a percentage. Okay, so in that case, we're talking about worth as a percentage. You're going to see both types of examples in our not only our lesson here today, but also your practice. Okay, your homework. Okay, worth as a percentage. And don't worry about that. I will show you examples for both. Okay, so sometimes you're dealing with monetary value, sometimes you're dealing with percentage values. That's what I'm saying. Now, when it comes to a fair share, which is one of the main concepts here, so let's highlight this, one of the main concepts, fair share. If there are n players, okay, n people, n could be 5 people, 6 people, or it could be 4 people in the groups of 4, like you guys are in groups of 4 right now, then a fair share is worth 1/nth, at least 1/nth, excuse me, at least, key words here, at least 1/nth, all right, of the total value. Excuse me. Okay, so if there are 5 people, then everybody gets 1/5 of the total value. If there are 3 people, then everybody gets 1/3 of the total value. If there's 2 people, then each gets a half, right? All right, so in general, if there's n people or n players or n groups, you always take 1/nth of the total and give that to each one. That's what's considered to be a fair share. And that means the following, okay? So that means that a fair share, let's define this mathematically here. A fair share is greater than or equal to, okay? That's what at least means right here. At least means greater than or equal to, all right, 1/nth of the total. 1/nth of the total value. Okay, and I'm talking about in dollars here, okay? Which means that you take the total and divide it by n. That's all it means. So the total value in money, all right, divided by n, where n stands for the number of players. So I can write that as the total divided by the number of players involved. Okay, that's all there is to it. So we're going to be talking about the fair share throughout all the examples. So let's get right into it. Okay, Paul is 1 out of 4 players. This is example 1, obviously. And if Paul's 1 out of 4 players, then everybody gets 1/4 as a fair share. The question is, what's 1/4 as a percentage? Okay, let's read on. So he values S1, which is your first good, okay, your first asset, at 12%. This is a percentage problem. S2 at 27%, S3 at 18%, and of S, okay, and S4 at 43% of S, where S is the total amount of goods. All right. Well, what is a fair share is greater than or equal to what percent? Well, if Paul is 1 out of 4 players, right here, 1/4, all right, 1/4, ooh, that's 4, all right, which is equal to, 25%. Just divide the two, 0.25 multiplied by 100, you get 25%, okay? So it is a fair share in this case is considered to be greater than or equal to, again, it's at least 1/nth, 1/4, or 25% of S, which is the total amount of goods, okay, of S. And this is the total amount of goods. So remember that. Now, which shares are fair to Paul? There's 2 questions here, A and B. All right, so which shares, S1, S2, S3, or S4, are considered fair to Paul? Well, anything greater than or equal to 25 cents would be fair. So S1, that would not be fair. S2, that's 27%, that would be fair. So S2 is fair at 27%. All right, S3 at 18%, that's not fair to him because it has to be greater than or equal to 25%. He doesn't consider S3 very highly. That's why his preference brings it down a little bit. And then S4, since it's at 43% of S, well, that's considered fair as well. So S4 at 43% is fair. So the key word is here. What considers to be fair to him? Well, based upon his preferences or his values, only the second and the fourth items are considered to be fair because they're greater than or equal to 25%. Now, example 2 is slightly different. These are not percentages. Here in this case, Jordan is 1 out of 5 players. Okay, so that's important. Let's highlight that too. So he's 1 out of 5 players. Now, he values S1 at $35. This is not a percent, okay? S2 at $40 and S3 at $23 and S4 at $22 and S5 at $30. Okay, we don't know the total in this problem, so what we need to do is figure that out first and figure out what would be considered a fair share. So what we need to do is calculate the total. So let's add these up. Okay, so total. Okay, S equals the total. All right, in this case, you have to add up all these little numbers right here, right? So 35 and 40 and 23 and 22 and 20 and 30. So let's do it. So 35 plus 40 plus 23 plus 22, that is, plus 30. Well, that is equal to a whopping 150 bucks. Okay, go ahead and check it on your calculator if you like. But what is considered to be a fair share for, in this case, Jordan? All right, well, he's 1 out of 5 players, right? He's 1 out of 5. So what we do is we take what's considered fair. Since he's 1 out of 5, you got to take your total, which is right up here, and divide it by the number of players. So fair share in this case would be equal to 150 bucks divided by 5, and that's obviously $30. So any one of the goods, S1 through S5, remember these are just assets. All right, he's got 5 assets or 5 different items or 5 different goods. Has to be over 35. It has to be greater than or equal, 30 has to be greater than or equal to 30. That's what we're looking for. So fair is greater than or equal to 30 bucks. So if we compare here, S1's 35, right? So that'd be fair for him to select that one. That's a fair share. 40 is a fair share, so S2 is 40. That's a fair share because it's greater than or equal to 30. Not S3 because it's only 23. Not S4 because it's less than 30. And then S5 would be considered fair too because fair share is always greater than or equal to that value. Just look up here in blue. Fair share is always greater than or equal to the total divided by n. So I'm going to say S5 is fair too because 30 is greater than or equal to 30, right? So we have 3 assets or goods that would be considered fair according to this problem right here and given the total. All right. The goal of any division game is so that each player gets a fair share. So the question is, how do you determine what's fair? And that's the whole essence of the chapter. All right, because I don't care what you're dividing, whether it's a piece of pizza, a pie, a cake, a piece of land, the chores in your house when you have multiple, let's say, kids. Let's say you're 1 of 3 kids. What's considered fair? What should each person do to have a fair share in the cleanup? If it's if they're splitting up chores, let's say, or responsibilities around the home. Now we need to make 4 assumptions about the players. Okay, and we're talking about rationality, cooperation, privacy, and symmetry. Now, when it comes to rationality, we have to assume that each player is a thinking, rational person or agent. Agent is person, okay? Seeking to maximize, all right, all right, the share of the goods, all right? You want them as much as possible, right? I mean, everybody wants that, so because we're human. We want to maximize our gain when in any division game, whatever it is, especially if it's a piece of pizza. I mean, if I love pizza, okay, so if there's multiple people involved at the table, not only do you want your share of the pizza, but you want to maximize it, okay, in terms of your own preferences, because there's different types of pizzas involved, right? So what that means is that the decisions are not based upon emotion or revenge, okay? Decisions, this is the implication. Decisions are not made. excuse me, based upon, emotion, nor revenge, okay? You can't make a decision, all right, to make it bad for the other person, okay? So no, you don't get emotional, you just think rationally and make your decisions based upon rationality. Now, you also, in terms of cooperation here, players must be willing, are participants, and accept the rules of the game. So, whatever the rules may be, once you're in the game and you're dividing things, you have to accept those rules once they are made. In respect to privacy, each player has no useful information about the other's value systems. Okay, you don't know their preferences. Okay, you don't know their preferences. And in respect to symmetry, what that means is that each player has equal rights to sharing the goods. Okay, everybody has equal rights when sharing the goods. All right, having said that, let's talk about some other aspects, or the different types actually, of a division game. Now, there's two types of divisions, or two types of goods in any division game. There's what is called continuous and what's called discrete. Now, they're different. Goods can either be classified in either way. So when it comes to continuous types of goods, we define it as goods being divisible in infinitely many ways, kind of like a piece of pizza or a cake. You can divide a cake any way you like, and you can split it up among however many people you want. So goods that are divisible in an infinitely many ways are called continuous. Okay, now I'm talking about pizza, for example. You can divide that up in as many parts as you want. The slice can be of any size. So no matter how many players are in the game, you can divide a pizza up easily here. A pie, a cake. Okay, you can divide those up in any way you like. Even a piece of land, most of the time, can be divided in an infinitely many ways. Okay, sometimes, given the restrictions of the settlement, that may differ. It may not be possible, but for the most part, you can divide land in an infinite many ways. Now, goods that cannot be divided up in infinitely many ways, they're not divisible, or what we say indivisible. Okay, you can't divide them. Are called discrete goods. Okay, and I'm talking about houses, for example. Okay, in a divorce, unfortunately, um, a house, everything inside the house has to be divided between the two people, and we're talking about the cars, we're talking about all the assets. Okay, you're talking about everything, including the jewelry, let's say too. Okay, so all these things, you can't divide a house in two because that wouldn't make any sense. You can't divide a car in two, so they're indivisible. So we call those discrete goods. Anything that cannot be divided uh, in a way that makes sense is called discrete. Anything you can divide in any way or shape is called continuous. All right, and sometimes it's mixed. Sometimes it's a little bit of both. So we're going to be taking a look at both of those situations and dealing with them one at a time. All right, so let's get into some concrete examples here so we can illustrate the idea behind what's considered to be the fair share. So in this example here, let's read it together here. 3 players, Anna, Ben, and Kara, must divide a cake. Okay, you're going to divide in a cake here among themselves. All right, we'll call these slices right here S1, S2, and S3 right here. S1, S2, and S3. The values of the entire cake um, is given. Okay, so for Anna's cake is $12, Ben's 15, and Kara's is 13.50 here. And the value of the entire cake, I'm sorry, I got a little lost train of thought there, is given, and also the values of each slice in the eyes of the players are also given. So, for example, in this first cake, Anna values the first slice at $3, the second at $5, and the third slice at $4. So notice that her values, these are the values right here, are given in the table here. And then in Ben's case, he values the first slice at $4 out of the 15, and the second one $4.50, and then the third one, well, he must really like it because he values it at $6.50. So notice that everybody values the slices differently given their individual cake. The question is, what is considered to be a fair share out of those slices? So let's take a look at Anna first. Okay, so this is 1, 2, 3. So take a look at the first row here, and let's figure out what would be considered to be a fair share. All right, so the first thing we do is we notice that there's the first cake is $12. So if you divide $12 into 3 slices equally, if you divide it equally, you got to take a third of 12. All right, now a third of 12 is 4, right? 12 divided by 3 is usually 4. So that would be considered to be a fair share if you divide the cake equally, which means that any slice greater than or equal to $4 would be fair to Anna. So any slice greater than or equal to $4 would be fair to Anna. All right, so let's compare these slices here. So S1 is $3, S2 is 5, that's greater than or equal to 4, and S4 is 4. So Anna would consider S2 and S3, S2 and S3 fair shares, all right, because they are greater than or equal to 4. So based upon her value system and based upon how she's valuing the slice, she would consider S2 and S3 to be fair and not S1 because 3 is obviously not greater than or equal to 4. So she would probably choose S2 or S3. Most likely S2 since that's, the highest valued one. Now in respect to Ben, we got a $15 cake, right? So if you divide it equally into 3 equal parts, into 3 slices, you got to take 1/3 of 15, which is 15 divided by 3 or 5. So $5 would be considered to be a fair share. All right, that means that any slice greater than or equal to $5 would be fair. All right, so which ones would Ben consider fair? Well, let me see, not this one here, that wouldn't be considered fair. 450 is not greater than or equal to 5, that wouldn't be fair, but 650 would. So the third slice, only S3 would be, which is 650, would be fair. Okay, based upon his value system. So how about Kara? All right, so her cake's 1350. So what's 1/3 of 1350? Well, you got to divide 1350 by 3, right? So let's do that. So take 1350, all right, divided by 3. Make sure you press the right buttons there. That's 450. So any slice greater than or equal to 450 would be considered fair to Kara. All right, so that means that any slice greater than or equal to 450 would be fair. All right, to Kara in this case. All right, and guess what? They're all 450, right? So she would consider any one of them to be fair. So S1, S2, and S3 all would be fair. All right, and that's all there is to it, guys. Okay, she could select any one of the slices because they're equally valued. All right. Now, let's get into a little bit more in-depth example here, one that involves some different divisions here. Okay, so in this case here, in example 2, we got a cake, all right? And we got a chocolate cake, C for chocolate cake. We got a strawberry. It's part strawberry and it's part vanilla. Okay, so V for vanilla, S for strawberry, C for chocolate. And we notice it's been divided into equal parts. We're talking about thirds now. So according to the problem here, Malia buys a chocolate strawberry vanilla cake shown in figure 1, and it's $11.20. So let's put that in. It's $11.20. Malia values strawberry twice as much as chocolate and values chocolate twice as much as vanilla. Find the value of each part of the cake based upon her value system. So what is the value of each one of these parts? Like out of the 1120, what does she consider to be, what's the value out of that for each one of these parts based upon her preferences? Well, we got to figure that out first, and then we'll divide up the cake and figure out the value of the pieces. All right, so in this case, let's take a look at it again. I always read problems more than once so that I understand the problem here. So in this case, Malia values strawberry twice as much as chocolate. Well, let me see, S for strawberry and C for chocolate, right? So S is equal to twice that of chocolate. So I'm going to say that S is equal to twice that of chocolate. So strawberry is valued twice as much as chocolate. So you would take chocolate multiplied by 2. All right, that's her first value. Okay, secondly, she values chocolate twice as much as vanilla. So let's talk about that. Ooh, okay, well, chocolate is equal to twice as much as vanilla. all right, in respect to her value system. The question is out of $11.20, what's the value of each part of the cake based upon her value system? Okay, because it's not for her, it's not 1120 divided by 3. They don't all have equal value. So let's figure that out. So that's our first step in the problem. So what we're going to do is we are going to do a little algebra here. We know that the strawberry plus the chocolate plus the vanilla here is equal to $11.20. Okay, I do know that. Well, let's see here. I know that the strawberry is twice that of the chocolate. She values twice that of the chocolate. I know that the chocolate, in considering her values, is twice the vanilla. So plus twice the vanilla here, plus the vanilla here. I'm just bringing down here. And it's all equal to $11.20. Okay, so now I've got an equation still with two variables. Okay, not good. All right, you know in algebra that you want one equation with one variable, so I'm going to substitute again. I know that chocolate here is twice the vanilla, so I'm going to say, well, chocolate is twice the vanilla, so I'm going to substitute two vanillas in for the chocolate here, plus 2v plus v is equal to 1120. Okay, so 2 times 2v is 4v, so we have 4v plus 2v plus v is equal to 1120. It's 4, 2 is 6, plus 1 more 7. So I got 7 times the vanilla equals 1120. All right, and then I'm going to bring it up here. So divide by 7. Okay, so V is equal to, all right, 1120 divided by 7. So $11.20 divided by 7. That's $1.60. Okay, so she actually values the vanilla at $1.60 because based upon her value system, it's not equally valued for the three parts. So the vanilla, has a value of $1.60 in her eyes. Okay. Now let's find the value of the other two pieces based upon her value system. For strawberry, it's 2 times chocolate, but I don't know the chocolate yet. So let's find the value of the chocolate first. So here, I want to take this, I want to substitute it over here, and I want to find the chocolate value. So the chocolate value is 2 times the vanilla value, so which is $1.60. And so the chocolate value is $3.20. That's a value. All right, so it has a value of $3.20. And then, of course, well, strawberry is 2 times the chocolate value, so you take this over here and you get the strawberry value is 2 times the chocolate value of $3.20. And that means the strawberry has a value of $6.40. Okay, so now I have all the values based upon her value system. So notice that this division problem wasn't just as simple as, hey, take 1120 divided by 3. No, okay. When it comes to the values in the problem, if everybody values things differently, then it's not as simple as dividing something into equal parts. You actually have to figure things out. So now that we have figured a few things out, let's answer a few questions. The value of the chocolate part is 320. The value of the strawberry part, 640. It has the highest value. She must like strawberry a lot. All right, and the vanilla part is the least liked, and it has the lowest value of $1.60. Okay, the question is, after you know those values here, if you divide the cake up into 6 pieces, 6 equal pieces, what's the value of each piece? All right, and that's this problem here. If the cake is cut into 6 equally sliced pieces, find the value of each piece. Each piece, find the value of each of the 6 slices. So that's what we want to do now. All right, so notice in the picture up here that the pieces, there are 6 equal pieces. All right, that's the first thing. So there's 6 equal sized pieces here. So the question is, what's the value of each piece? And notice piece 1 is vanilla right here. It's taken out of the vanilla right here. It can't have a value of $1.60 because it's obviously doesn't contain all the vanilla in it. The entire vanilla portion is $1.60, so this piece has to be less than that. The question is, what is it? What portion of the vanilla does this represent? That's what we need to figure out. So if you consider this in a geometric way, it might help you a little bit. So let's go back to the original diagram. The cake was divided up into thirds. Okay, so let's draw thirds. Draw what looks like the Mercedes symbol here. Okay, 3 equal parts. Divide into thirds. All right, and if you do that, if we can determine the angles here. So we're just going back and doing a simple little geometry problem here, because I think dealing with the angles will make it a lot easier. So the question is, what are these angles right here? Well, we know that they all add up to 360. And so if you divide it into thirds, all right, 3 equal parts, you got to take 360 and divide it by 3. Now 360 divided by 3 is 120. All right, so each of these angles is 120 degrees. They're called central angles in geometry. All right, so that's equal to 120. All right, so if you take the cake here and divide it into 6 equal pieces, well, you got a piece here and you got a piece here. You got to take half of this. You got to take half of, there you go, and there you go. So this angle now is 60. They're all 60 degrees. So this now is a 60-degree angle. And you'll notice, let me highlight the vanilla first here. So here's your vanilla portion right here. Is that this piece right here, 60, is basically half of the 120 in respect to the original portion of the vanilla in the cake on the left here in the first figure. You could also tell it's half because if you divide this in half, let's say take a piece right here. Okay, you notice that I could divide this piece number 1 into 2 pieces right here. There's 1, 2, 3, 4 parts of it, right? There's now 4 equally little slices of vanilla, and this is 2 out of 4, or a half. So I can see that piece 1 has half of the vanilla. But what we're going to do is we're going to use portions, okay? We're going to take the angles out of the whole here to represent your portions, because I need to figure out what portion of the vanilla this represents, and that portion I'm going to multiply by $1.60 so I can get the value of each piece, you know, because I don't know what the value is. What is this worth based upon our value system? So let's go down here and let's write down the slices here, and we'll call P1 for piece number 1. I do know that looking at the picture, so I'll have to scroll up and down here, is that it's 60 degrees out of the original 120, because remember, vanilla is 1/3 of the cake, or 100 degrees out of the circle, right? So 60 out of 120 is a half, or you can just think, okay, there's 4 little parts here, and I've got 2 parts out of the 4 parts of vanilla. So it has to be half. All right, but I'm going to use the angles in the problem to help me, because this is going to help you with other problems in your homework. So 60 out of 120 is the portion of vanilla that we're dealing with, which is a half, and I want to take the portion of its value, and the value of the vanilla portion is $1.60, so we multiply it by its value to figure out the value of the piece, okay? So then I do a little simplifying here, cancel out the lead zeros, 6/12 is 1/2, so I get 1/2 of $1.60. Now half of $1.60 is $1.60 divided by 2, right? So if you can't do the division in your head, don't worry about it. It's $1.60 here divided by 2, it's 80 cents. All right. So this portion, this is piece 1 here, has a value of 80 cents. All right. What is the value of piece number 2? Well, let's see. It's half vanilla and half strawberry. Now, if you half a 60, if I divide this right here, this piece, this is 30 and this is 30 here, 30 and 30 is 60. So these little angles here, if you want to consider them angles, are both 30 degrees. There we go. All right, so this little vanilla piece is actually 1 part out of the 4 vanilla parts, or 1/4 of it. Another way you can get that is 30 out of 120. Okay, because remember the original angle in the strawberry, here's strawberry right here, that's 120 degrees, right? Because it's 1/3 of the cake. So 30 out of 120 is 1/4, and you can see that because the vanilla portion right here is 1 part out of 4. But I'm going to use angles again because a lot of problems deal with angles, as you're going to find out. So in respect to piece 2, the vanilla portion of it is 30 out of 120 times its value. The vanilla value is $1.60. All right, plus the value of the other part of the slice. Now it's part vanilla and part strawberry, but strawberry has a different value, right? It's valued at $6.40 for that third of the cake. So it's 30 out of 120 times its value of $6.40. So 30 out of 120 times $6.40. So this right here, if you simplify 3/12, you get a fourth. And you got to take a fourth of 160 plus 1/4 of 640. Now, so we know that this is 40 cents. A fourth of 640. So you take $6.40 divided by 4. All right, and you get $1.60. So if you add that up, you get $2. $1.60 plus 40 cents is $2. So piece number 2 has a value of $2. It's valued more. Okay, $2 value. So it's a higher valued piece considered to piece 1. So if she had to choose, she would choose piece 2 over piece 1. Now piece 3, it's pure strawberry. So what's its value? Well, let's see here. This portion of the strawberry right here, if you take a look at it, just conceptually right here, here's your piece. Notice there's 1, 2, 3 smaller parts of strawberry, and I've got 2 out of 4 parts, so it's half of the strawberry. All right, so it's going to be half of 640. But in respect to angles, it's the 60-degree angle here, because 30 and 30 is 60 here, out of the 120. So piece number 3, in terms of angles, is 60 out of 120 times is a value of the strawberry, because again, it's a portion of the value. It's not 640, okay? That's for the third of the cake, all right? We're talking about what would piece 3 be? So it's a portion of 640, and if you simplify, you get 6 halves, or 6/12, or 1/2, and it's a half of 640. All right, 640 divided by 2 is 320. So it has a value of $3.20. So it is the highest priced, or the highest valued piece so far. The question is, what's the value for the other 3 pieces? So piece number 4, let's try that. It's part strawberry and part chocolate. Ooh. So let's take, again, these angles are 30 degrees, right? Half of 60 is 30. So 30 out of 120. Again, the original angles over here on the cake on the left are 120 because you split up into thirds. So it's 30 out of 120 times the value of the strawberry, which is 640. So piece 4 would be 30 out of 120 times the value of the strawberry at 640. Now it's part chocolate too, so 30 out of 120 times the value of the chocolate. What's the value of the chocolate? Well, it's 320. So you simplify and you get 1/4 of 640 times 1/4 of 320. So let's figure that out. So 640 divided by 4 is 160. 1/4 of 320, that's got to be 80 cents. So 320 divided by 4, it's 80 cents. And that's 240. Okay, so the value of piece 4 is $2.40. So what's the value of piece 5? That's pure chocolate. Okay, well, it's a fourth of the chocolate here. However, let's do with angles here. That's a 60-degree angle. So it's 60 out of 120 times the value of the chocolate, which is 320. So it's a fourth of 320. So piece 5, which is pure chocolate, is, oh, come on, Ainsworth here. Let me fix that. The angle is 60 out of 120 times the value of the chocolate. The value of the chocolate, as we stated right here at the top, is 320. And that's 1/2 of 320, which is $1.60. Okay, let me verify that. So $3.20 divided by 2. Oh, you got to, come on, Ainsworth. 320, you got to put the press the right buttons here, divided by 2, and that's $1.60. All right, now what is the last piece value? So this right here has a value of $1.60. Now, piece 6 is a combination. It's half vanilla and half chocolate. So the chocolate portion here is going to be a fourth. There's 1, 2, 3, 4 slices. This is 1 out of 4, so it's a fourth. But let's do it with angles. So 30 degrees out of 120 times the value of the chocolate, which is 320. So 30 out of 120 times 320 plus the value of the other part of the cake. It's part vanilla, so it's 30 out of 120 times the value of the vanilla, which is only $1.60 because it has the least value. So 30 out of 120 times $1.60. So simplify, you get 1/4 of 320 plus 1/4 of 160. This is 80 cents and this is 40 cents. So it has a combined value of $100.20. So let's go up top and let's denote that. So this has a value of $1.20. Okay, so if you add up all these values right here, it's obviously $11.20. And notice in the problem here, based upon the original value system, each piece has a different value. And then you can go and say, hey, which would be considered fair? You know, which would be considered fair based upon her value system? And so, let's see here. What's 11.20 divided by 3? All right. So, yeah, so at $3, any slice over $3.74 would be considered fair according to her value system. Well, I'm talking about here in figure number 1. Only the strawberry would be considered fair according to Malia, okay? But in respect to all the individual slices here, this is the individual values based upon her value system given in the problem. And notice that preference makes a huge difference. It's not as simple as, hey, just divide the cake into 3 equal parts and divide 11.20 by 3 and assign the value. No, preferences matter and it changes the problem. Okay, and it changes the value system or the worth of each piece in this case in respect to the cake. All right, so that's a couple good examples of how values change the values of the problem and the conditions of the problem. What you guys need to do is try your homework here, all right, which is included right here, all right, on the next page. So get started. You're going to be working from 1 through 10, except number 4. And to give it your best shot. And remember, this is a video, right? So if you like, you can replay and rewind and listen to any portion you want again. All right, so use it to your advantage. This is Mr. Ainsworth. This was your first lesson on division. All right, we call this fair division, or chapter 3, section 1 in the modern math or discrete textbook, okay? And I'll see you in my next lesson in section 2. This is Ainsworth. I'm out of here. Bye-bye.